Hello students, welcome back to my YouTube channel Data Shah. In this lecture, we'll be talking about Vogel's approximation method. It's another method for the transportation problems and it is the one of the best methods. So in this method, each allocation is made on the basis of the opportunities. That means the penalty that we will be calculating that would have been incurred if allocations in certain cells with minimum unit transportation cost were missed. It is also known as the unit penalty cost method, and the steps that we have to follow is as follows. It is preferred over the previous two methods because the initial feasible solution that is obtained is either optimal or very close to the optimal solution. So that's why we always prefer the VAM method. It is the also called as VAM method. Step 1. Compute the penalty for each row and column in the transportation table. So how we can calculate the penalty? Penalty is basically the difference between the smallest and the second smallest cost in the rows and in the columns. So we have to calculate the penalties for every row and for every column. Step 2 is identify the row or the column with the largest penalty. So that particular row or column will be taken as the first cell. We have to repeat this until we get all the allocations that is required for us. So let us consider one example. This is the same example that we have taken in the northwest corner method and in the least cost method. So let us consider how do we calculate the penalty. First of all, we have to check it's a balanced transportation problem. Now the penalty would be in the first row the minimum is 6 and then it is 8. So 6 minus 8 would be 2. So I can write 2 here like this. Now in the next it's 7 and 11. So 11 minus 7 is 4. Next third row, 4 is the lowest, 5 is the second lowest. So it's 5 minus 4, 1. Similarly, I'll be calculating the penalties for the column. In the first column, the lowest is 4, second lowest is 6, so it becomes 2. In the second column, the lowest is 5, second lowest is 8, it becomes 3. Similarly, for the third column, 10 and 11, so 1. Now I have to choose the penalty which is maximum of all the penalties. So either it would be the rows or the columns. The maximum penalty that we are having here is this. So 4 is the maximum penalty. That means we have to consider this particular row. In this particular row, the minimum cost that we have is 7. So we'll be going with this particular cell. Now the rest of the steps remains the same that we have applied in the northwest corner method and the least cost method. So of the demand and the supply in this particular cell, the minimum is 175. So I'll be allocating 175 units here and this becomes 0 and 200 minus 175 is 25. So this is how we'll be doing it. Now in this that as we cannot for the source 2 we cannot give any more units because the supply is 0. So I'll be deleting this row. I'll be not considering this row. So there is nothing possible in this particular row, so we can also add a dash. Now the step again we have to calculate the penalties. So here again this is 8 minus 6, this is 5 minus 4. For the columns now it is 6 minus 4, 8 minus 5. Earlier 11 minus 10 we did, now 11 is gone. So it would be 12 minus 10, that is 2. So we cannot consider this particular row, the dotted row that I have marked. So you have to exempt this. Now again you have to choose the most maximum penalty. Now the maximum penalty is 3. So I'll be considering this particular column. In this particular column, I'll be considering this cell or this cell. I have only 2 cells. I'll not be considering the source 2 in this case, only the source 1 going to B and source 3 going to destination B. So out of these two, 5 is the minimum cost. So again, choose the minimum of the demand and supply. Minimum is the demand 100, so I'll be allocating 100 here. This becomes 0, so this is now 175. Now the same procedure, I can't allocate anything here, so I'll be just deleting this particular row, or you can add a dash like this. This simplifies that you cannot count any more penalty, and this particular row or column is gone. Now calculating the penalties again for the row, now it would be 10 minus 6, so that's 4. Leaving this row, 12 minus 4, it becomes 8. 6 minus 4, again 2. 12 minus 10, again 2. So the maximum that we have now is 8. So considering this particular row, in this particular row, the minimum the cost that we have is 4. So again, the minimum of the demand and supply for this particular cell is 25. So I'll be allocating 25 here. Now this becomes 175 minus 25, that's 150. So again, we'll not be taking this particular row, we'll not be taking this particular column forward. So this would be, and I'll draw a dash here. It is not necessary that whatever particular column or row you are taking, every time you have to, that will be the going one, right? So next, calculating the penalties again, this would be 2. Here it would be, because we have just single column, and there is no particular column here, so you will be just taking this particular column only. In this, the minimum cell is 10, so I'll be first taking 10 here. So here it would be 150 supply, 300 supply, so the minimum is 150. So allocating 150 units from source 1 to source destination C, it becomes 0. And the last that we have is 150 for the demand, 150 for the supply, from source 3 to the destination C, so it is 150. So as we know, the positive allocations that we use to calculate is m plus n minus 1. So that's equal to 6 minus 1, which is equal to 5. So we can see that we have 5 positive allocations. So we have got the degenerate basic solution. Now the minimum cost we can calculate, that would be equal to 175 into 7, 25 into 4, plus 150 into 10, 100 into 5, plus 150 into 12. And we can calculate the minimum cost, and we could check that with the northwest corner method and the least cost method, we obtained the minimum in this case. So 175 multiplied by 7 is equal to 1225. 25 into 4 is 100. This is 1500. This is 500. And 150 into 12 is 1800. So this is 2000. 2000 plus 1800 is 3800, plus 100 is 3900, plus 1225 is 5125. So this is how we could calculate the minimum cost. So now moving ahead with the next example. This is the same example that we have done in the previous two methods as well. So again, first of all, we'll check that it's a balanced transportation problem. Now the same process we'll be applying every time. So let us calculate the penalties. Here we have three sources and five destinations. So m plus n minus 1 would be 8 minus 1. That's 7 positive allocations we are looking out for. So here 2 and 3, so that's 1. 1 and 1, so that's 0. 3 and 4, again that's 1. 2 and 1, 1. 9 minus 4, that's 5. 7 minus 4, 3. 3 minus 2, and 7 minus 1, that's 6. So the highest allocation that we have here is the maximum penalty, that we have is 6. So considering the least cost here, that is 1. So from the source Y going to the destination E, the demand is 6 and the supply is 8. So the minimum is 6. So this becomes 0, and here this is 2. So now as we know, this is gone. So I'll be just removing this particular row, or you can just add a dash here. So it this signifies that we cannot count the penalty now in this particular column. We'll not be considering this particular column. This would again be 1. This is 1. Now this is again 1. There is no change in this. It remains same. So now the maximum penalty that we'll be considering is 5. So in this particular column, 4 is the minimum. So out of supply 2 and demand 3, 2 is the minimum. So this becomes 0, and here this is 1. Now as we could see here, we can't allocate any more for the from the source Y to any other destination. So I'll be just removing this, or I can just add a dash here. Now calculating the penalties again. So this is 1, and this is 11 minus 9. Now this is 10 minus 4 is 6. 8 minus 3 is 5. There is no change in this. This remains as it is. Now the maximum that we have is 6. The maximum penalty. The minimum cost cell is 4. So out of 12 and 4, the minimum is 4. So I'll be allocating 4 here. This becomes 0. 12 minus 4 is 8. So this was 9. So out of 9 and 4, 4 is the minimum. So this is 5. So now removing this particular column and add a dash here. So can't calculate the penalty in this case. So again the penalties would be same in this. Here there would be a change, so we can calculate, and this would be 3 and 8. So 8 minus 3 is 5. So here you would see that we are having a tie between the penalties 5 and 5 here. So you can choose any of them. That's particularly your choice, whichever you want to choose. So if I'll be considering this one, then if I'll take this, so this is the minimum one, 3. So the minimum cost cell. So out of 5 and 4, 4 is the minimum, so this is gone, and I'll allocate 4. This becomes 1. So that means again this row is gone, so I'll just add a dotted line, and we can't take this particular row. That means source X cannot give anything to any of the destinations. Now we have just single row, that is for the Z, and in the Z only we'll be finding out the minimum cost cell. So the minimum cost cell that we have is 3. So out of 3 demand and 5, we have 3 is the minimum. So I'll be giving 3 here units. This becomes 2. Now 9 and 8, 8 is the minimum. So 1 is the unit that will be allocated. This would be 1. Now we will not be calculating any penalty because we are having just single row here, and this is also 1. This becomes 0. Demand and both supply are equal. So we could easily see that we are having 7 positive allocations: 1 2 3 4 5 6 7, and with this we can calculate the minimum cost, and the minimum cost would be 12, 8, 6, 9, 9, 16 and 8. I repeat again, you just have to multiply the number of the units, that is 4, with the unit cost 3, so I'll get 12. Number of the units, that is 2, with the unit cost 4, so that's 8. That's how we can calculate the minimum cost. So that's coming out to be 26 plus 18 plus 16 plus 8, so that's 68. And previously we had in hundreds, so you can cross check. So this is how we can calculate the using the VAM method the initial feasible solution, and it is almost closer to the optimal solution. Now in this case, if you'll consider again, it's a balanced one, so we could calculate it again. So this would be the exercise. You can practice this, you can try it, the balanced transportation problem, and in the next lecture I'll be taking the examples of the unbalanced transportation problems.